So now I want to introduce our speakers, Jeff Barron and Gale Kimbrough. Between the two of them, they have almost 100 years of automotive and battery and running a shop experience. So, guys, how are y'all doing today?
Doing great.
Doing great.
All right.
Good to be here.
Cool. So they're going to take us through, let me just show you an outline of what we're going to go through today. We're going to first have a few minutes, maybe 3 or 4 minutes on the industry, marine and RV industries, what consumers are buying, what they're looking for, and the demands on batteries. Then we'll talk about the supply situation with batteries, just like with any other parts. Batteries are constrained this year, so we're going to talk about that and how you can get the most out of every battery and help your customer get the most out of every battery by specifying the right battery for their needs, understanding battery types, battery chemistries, like I said, that setup, understanding amp draw, calculating amp draw, and then we'll talk about maintenance best practices, including charging. So without further ado, let us kick it off. So it probably comes as a little surprise to most of the people in this call. Both the boat and the RV industry are doing really well. You can see here that shipments of new equipment is up just about to record highs in both categories. Another thing that we looked at specifically to RV owners, we looked at the percentage of households that either own or intend to own an RV. If you look at that, it's 25% of all U.S. households, right? Looking at 32 million U.S. households that either own or want to own an RV. And the trend and the features that they want most from their RVs are basically the ability to go off-grid or dry camping. So that means house batteries, that's a bank of several batteries, generators, solar panels. All of these speak to battery demand. Specifically to the marine industry, we look at aftermarket accessory spending, and that exceeded over $9 billion in 2020. It's just extra electrification and extra demand on batteries. One of the articles that I looked at in preparing for this was a quote from the CEO of Brunswick, Dave Folks, who said, a big question for the industry is how do you keep people interested in it, right? How do we keep them all in boating and, presumably in RVs also? And the key factor, he said, would be how their ownership experience goes. And at Interstate, we believe that batteries have a big part to play in that positive experience. If someone's in an RV across the country and their battery dies and they bought a local brand battery, can't replace it there, that's not a good experience. That's a real hassle. Similarly, in a boat, if the battery conks out sooner than it should have, that's not a good experience. So we've prepared this to tell you about some new products that we have that will help, but also to help you educate your customers on how they can get the most out of every battery. And right now this is more important than ever because, as you're probably aware, many manufacturers are experiencing supply constraints of their own. Shipping costs are high, labor costs are high, labor is unavailable, not to mention near record inflation. So to make up for those expenses, they're prioritizing their automotive lines. They're shifting over to non-automotive production less and less. And that means there's going to be fewer marine RV batteries. So it's more important than ever that we look at different alternatives, different chemistries, AGM, lithium, but also a new enhanced flooded technology that's new to the US, been in Europe for a decade, but new here, and Interstate is bringing it to the market. We'll talk more about those, but looking at alternatives and then also helping our customers make the most out of every battery they have, get every amp out of every battery to help them have a positive experience and keep them in boating, keep them in RVing. So that's what we're going to talk about the rest of our time. And with that, I'm going to hand it over to Jeff and Gale. Jeff, how do we help them get the most out of their batteries?
All right. So folks, let's help your customers and let's actually get every amp out of the battery that we can actually get. So today we're going to talk about battery types. We're going to talk about the chemistries as well. We are going to talk about calculating amp draw and battery banks. Imagine that, part of this, huh? And we are going to talk about not forgetting to do battery maintenance.
And that's very important. First of all, let's start by talking about the types of batteries. Starting batteries and deep cycle batteries. You have a starting battery in your vehicle. You need it for that quick burst of energy. Driving down the road, it's recharged or at least maintained by the alternator, etc. But then you have deep cycle batteries that you're going to use for accessories in your RV or your boat, etc. So there's a lot of difference between those two types of batteries, how they're manufactured and how they're maintained. And so specifications, let's talk about that. Marine cranking amps. That's the number of amps a battery can deliver at 32 degrees Fahrenheit for 30 seconds while maintaining 1.2 volts per cell. And remember that number that you may see on a marine RV battery is 25% higher than you're going to see on co-cranking amp batteries for your starting. So, for example, you might see 700 MCAs, marine cranking amps, and that's actually equal to about 550 CCAs. So, because it is at rated at 32 degrees Fahrenheit versus 0 degrees Fahrenheit. So, co-cranking amps, same thing, except it's tested at 0 degrees. Common misunderstandings: using a starting batteries as a deep cycle battery. Negative. No, shouldn't do that. That's not going to last very long. It's made for one purpose: quick burst of energy starting the vehicle. It's not made for deep cycle. And not maintaining it, not adding the water that you need to, or maintain the battery. On deep cycle batteries, oftentimes they need to be maintained.
Exactly. So, well, and we talk about what you were just prefacing there was the starting versus the deep cycle.
Yeah.
So what we look at when we're looking at cycles. So everybody asks, well, how many cycles can I get out of it? Well, what we're looking at is one discharge and one recharge actually gets you one cycle. All right. So now we need to know how many number of cycles can I actually get versus what I'm looking at depth of discharge as well.
Yes.
So we look at that, and we'll kind of break that down as we're going through here as well. So the specs really matter on this. So your ampere hour or your reserve capacity, the minutes that a battery can actually deliver 25 amps at 80 degrees is what you're going to see with the reserve capacity number.
Yes.
And this is without falling below 10.5 volts. These are standard tests that we run here in the lab to make sure that our batteries meet the specs that we're putting on them. All right? So common misunderstandings here, though, is folks don't realize that there is a break-in period for deep cycle batteries. This is the one misconception that everybody just kind of gets confused on. So years ago, we used to say, take these batteries all the way down to 100% depth of discharge and then recharge them back up, and you're going to get them woke up.
That's not what your granddaddy said.
That's right. My granddaddy
Exactly.
used to say that. Well, that's not necessarily the case. These things, deep cycle batteries, can take anywhere from 25 to 50 cycles to get broke in. So we need to educate our customers before we actually sell these batteries out there.
We get so many calls about that.
Oh, my word, almost every day.
Yes.
And one of the other things that we always get hit with, too, is they always tell me, well, I'm charging my batteries, I'm going down the road.
Yeah.
Because my alternator, I'm towing my trailer, well, I'm charging that battery back there, too. That's not the case, folks. So realize that you've got anywhere from 10 to 20 to 30 to even longer gaps of wire before you get to those batteries that you've got on there.
And you're losing voltage.
There's what we
wire.
call that is a voltage
Voltage
drop. Exactly. So basically, the other thing that is also a misconception is folks say, hey, look, I'm going to use my batteries, and then I'll charge them once I get back to the house, which will be 3 or 4 days later.
Right.
Is that good on a battery?
No, they need to charge it as soon as possible.
Exactly. And also, we run into folks that really don't want to spend any money on batteries, right?
Absolutely.
And so they underspec what they're going to be using. Folks, that's not a good thing, because what you're doing is you're putting yourself in danger of not being able to accomplish the loads whenever you're needing them.
Absolutely. Cheaper is not better in that
Exactly.
situation.
And you got to charge them.
Yes.
Believe it or
charge
not.
them correctly. We have different types of battery chemistries that we need to deal with or understand a little bit more about. For example, we've dealt with our traditional flooded lead acid batteries for a number of years.
Yes.
And yes, they might have to have a little water addition occasionally. But now we have absorbed glass matter, AGM type batteries that are completely sealed, that you can't add any water to them.
Or you don't want to, right?
Or you don't want to. And there's also a couple of types of AGMs. There's the alloy type that we know about, and the pure lead that we know about, and that's conditional upon the type of lead that's inside the battery. We have lithium batteries that are coming on the scene. In fact, you're testing some of those in the lab right now.
Yes, sir, we are. It's
Yes.
so
Yes.
lithium now it's a whole different design to where it's a lithium phosphate, which is less volatile.
Also new to to what we have now, in addition, is an enhanced flooded battery. They've taken the flooded battery and added chemicals inside that to give it longevity, give it strength, give it robustness that we don't have in some of the batteries today.
Exactly.
So that's also a new addition in the enhanced flooded batteries.
I'm going to interrupt for just a second to remind everybody, if you have any questions, please put them in the Q&A tool. You can see that on your Zoom menu bar. We want to answer those questions, and we know that there are a lot of questions around deep cycle batteries. Now we're going to cut to a little video that Jeff and I made of him doing a teardown at our lab, running a battery, an EFB battery, through a bandsaw, looking at the plates, looking at the paste components, the grid, all the things that make this battery special. All right, Jeff, what are we looking at?
So we're going to take this cell out of here. It's one individual cell for it. So right now we're going to be looking at the negative plate. And as you can see, there's a lot of paste material that's on here still. This battery's gone through a lot of cycling, because as you looked at the edge of the battery, or the end of the case of the battery itself, you're going to see how it was swollen out, and that's because this thing has been through a bunch of cycles. And
this is one of the batteries you were testing?
Yes, that is correct. So this went through our European norm test, which is the 17.5, and we looked at the different number of cycles that we do a week, which is typically 85 cycles a week. So we got roughly 16 to actually anywhere from 16 to 24 weeks.
So that's your thicker strap?
This is the positive strap, yes, and as you can see, it's a little bit different color than what the negative is if you were looking at it head on. Kind of a gray versus a red, and that's just because it's the different chemistry in there.
Okay.
So we're looking at a poly envelope here, and this poly envelope is actually going to have the positive plate inside it.
So the positive plate's inside an envelope.
Yep.
Yeah.
And once we do that as well, we got what we call a scrim, which is actually kind of like your bonding agent.
Hold that up to the light.
Let's see.
Yeah, there you go.
There we go.
It's really thin.
Yeah.
Okay.
So this basically acts almost like rebar when you're looking at concrete. So this is actually applied to the plate itself while it's still moist. So the paste material is still going to be kind of wet, and then it's actually put on there so it kind of sandwiches everything together. So this is actually on both sides of the positive plate as well.
Okay, so you've got scrim outside the plate,
Yep.
inside an envelope. So
Yep.
extra protection, so less
So when you look
shedding.
so when you look at paste shedding, normally if you don't have this scrim on there, the paste is basically just going to start dropping to the bottom of the envelope. Well, with this, it kind of keeps it there to where it's not going anywhere.
Gotcha.
So when you look at cycles, you're looking at a lot more cycles because of that. Now you've got carbon also added in there. You've got several other different chemistries that are baked within this, the material, to be able to function through partial states of charge throughout the life of the battery itself.
Okay.
And this actually looks very good, you know, considering this one I believe was 17 weeks on the 17.5% DOD, which is extraordinary. So paste material still bonded really good to the grid itself, still pliable. We can actually bend it around and nothing breaks off. I mean, it's...
And how is that grid? It, you know, is pretty thick.
Oh yeah.
Be like the lead plates on
So
there?
let's, if you can get kind of a close shot there on the thickness of it. I mean, we're probably looking at 0.040 on the thickness of the grid, which is extremely thick for an EFB product as well. We offer these different grades now to be able to help the end user pick which battery they're actually going to need to work with the system that they've got. So we've got good,
Yes.
we've got better, and we've got the best.
The best.
And then we got a best, right?
Yeah.
Or we will. So we're working on the lithium program now to be able, and we'll talk about this too as well, that we're trying to integrate into our Interstate system as well.
Yes, absolutely.
So we talk about the enhanced flooded batteries, Gale, and
Yes.
I mean, there's been a lot of talk and speculation about this over the years. So, you know, developed over in Europe, we actually brought this into the US now to be able to help some of the start-stop vehicles now. So it's got a different way that it actually is designed to cycle. So it's got a high-life pace cycle in there that can really help out throughout deep cycling and some of the starting applications. It's also got a reinforced positive strap with a glass separator in there. So this is actually designed to be able to help you, and it's got a lot of vibration resistance built in there too. So it's going to help you be able to cycle this battery down and recharge it up, and it's maintenance free, Gale.
And so what you're saying is the negative, the positive, and a lot of other enhancements chemically and lead-wise strengthening
Exactly.
in that battery.
So you've got a graphite additive in there.
Correct.
On this separator, or excuse me, on the negative grid itself, you've got a what we call a scrim, and it's almost like a fiber mesh that actually keeps everything tightly compressed in there too.
Integrates it
Exactly.
into the paste material.
So our key benefits on this thing is, Gale, we've got a performance that is really close to an alloyed AGM,
Yeah.
but not the price.
Yeah.
All right.
That's important.
So we also got 2 times the cycle life as a traditional flooded battery. So that's another key factor to focus in on. And we give it a 2-year warranty on it.
And the dealer needs to know about these types of variations to be able to tell that individual customer about all these different types of batteries.
Exactly.
And the chemistries and the importance of each.
Bingo. And once again, it's maintenance free.
Absolutely.
Not all of us like to do maintenance, right?
No. I've heard people that don't.
Yeah.
Put it in there and forget it.
Exactly. I'll let you talk about some of this AGM material.
Okay, we have AGM, which is an absorbed glass mat battery. It's a true dual purpose type battery, cranking, cycling, and it's more expensive but twice the cycle life. And vibration resistance. Vibration resistance is very important in the marine RV industry, whether you're in a boat going across the water and you're bouncing back and forth, or you've got a lot of vibration because it's on the second trailer back there and it's getting a lot of vibration. Maintenance free, that's very important. Put it in there, forget it. And then faster recharging in that situation. You don't have time to let it set days. It'll faster recharge. And overcharging always affects battery life. So making sure that you charge it within the parameters that you're supposed to and according to the original equipment manufacturer.
Exactly. And keep in mind, we've got this differing battery chemistries that are coming out there as well. So this lithium, as we were talking about just a few minutes ago, lithium has been a very scary talk for a lot of folks out there.
Yes, for many years.
There has been a lot of things that have changed throughout the industry with this lithium as well. So we're looking at lithium phosphate.
Yes.
So these things now actually have what we call a BMS. It's a battery monitoring system. So it's a small circuit board that's actually encased in that battery itself, and it's monitoring every individual cell that's within that battery.
So that it doesn't overheat.
Exactly. And we don't want it to get out of parameters,
Yes.
right? Like Boeing had theirs where it had the thermal runaway.
Right.
Well, this lithium phosphate now with these BMSs actually control that to where it won't let it overcharge.
That's a great safety
Yes,
feature.
and it won't let it undercharge.
Right.
So when we're looking at all these different features now, these are the key components to look at. So they are, lighter weight. You can get 1,700 plus, or we've actually got 1,700 cycles on some batteries in here right now that we're testing, and that's at 100% depth of discharge.
That's
So
amazing.
we're taking this battery down to where it can't pull anymore, and then we're turning around and we're charging it right back up, and we're keep doing the same thing. So it's got the longest life of any battery that's out there. Plus, lightweight, we can actually do curls with these versus some of the other ones. And, there are also some space savers too, because when you look at ampere hours and you're looking at weight, so now, let's just say you wanted to buy 6 of them, right? At $1,000 apiece.
Yeah, that's $1,000.
Yeah, so we've got a lot less weight on there now. I will tell you though, lithium in any application does not like cold weather.
I don't like cold weather.
I don't either. So you can actually hamper it, and the units themselves, if that BMS is monitoring it and it sees cold weather, it doesn't want to work.
So you need to keep these batteries in an environment above 32 degrees Fahrenheit.
Exactly.
Or 0 degrees Celsius. For it to make sure, or for it to work properly within the confines of what you're trying to use it for.
Exactly. And some of the key features now, and especially with the charging side of it, there are a lot of the chargers that are out there on the market now that are actually designed to do lithium or AGM.
Right.
Because of the close profile that they're designed with.
This is what consumers need to know, or the misunderstandings that they don't know. And that's some of the things that we're going to follow up now with. For example, understanding battery ratings. On your starting batteries, you follow the OE spec, but on the deep cycle batteries, you may have waffle makers, you've got blow dryers, you've got crock pots, you've got all these accessories, fish finders, fish locators, trolling motors, lights, camera action, all of the whole thing there. So we need to make sure that we cover, or you cover, what is needed on the amount of amps, and the amount of hours that you're going to be utilizing this. For example, we have an estimating battery needs chart here, and this is talking about lights. 5 amps for 5 hours equals 25 ampere hours. Fish locator, 1 amp for 5 hours, 5 ampere hours. Trolling motor, 10 amps, 5 hours, 50 ampere hour. That's when the fish are very difficult to find, by the way. Anyway, and then you have a minimum requirement here now of 80 ampere hour, but let's stop right there for just a moment. And let's double that number, because we want the batteries not to go below 50% depth of discharge. That means you're looking for a battery that's got to cover 160 ampere hours to make sure you have adequate amount of power and don't go below 50% depth of discharge. If the battery doesn't have an ampere hour rating on the top of the battery, multiply that reserve capacity rating by 0.6. That's an approximation to convert from reserve capacity to ampere hour.
Exactly. So let's kind of understand the battery ratings here as well. So when you're looking at equipment on these coaches or in your boat, you know, if you've got an elaborate boat or whatever, typically all you're going to see is watts. Well, watts is, you know, you can actually do the conversion on this. It's really simple. So we're looking at our example here where we've got an LCD that's actually putting, you know, 200 watts out, right? And so for 30 minutes, you know, we're looking at 9.3 amps that we're actually going to be drawing. And we're going to do this for 1 hour, so we're going to equal up 18.6 ampere hours. So the way we figure this out, so we start with the AC power here, and we look at converting the watts over. So start with the AC watts, and you divide that by 12. By 12, well, that's a 12-volt system. Well, now we're going through this inverter, so we got a voltage loss. So we're going to have to actually times that by 1.1
Yes.
in order to get our loss there. And then we take that number, Gale, and we do it by how many hours we want to run. So we times that together. So our example over here, 200 watts on this TV, and we divide that by 12, so we come up with 16.6 amps.
Yes.
Hey, well, that's great. But I got to do that times 1.1 because of the voltage loss.
10% loss.
Exactly.
Yes.
So now I'm looking at 18.3 amps that I'm going to be pulling. And I'm going to do this for 2 hours.
Yes.
Right? So, because that's, you know, my wife wants to watch TV.
Notebook.
Yeah, exactly, the notebook. Good night. So now I need 36.6 ampere hours to make that 50%, or excuse me, the 2 hours that we're looking at it. So now I'm going to take that, and as you were talking just a minute ago, I've got to double that because of 50% depth of discharge. So now I need at least 73 ampere hours worth of a battery to be able to run this accessory for 50% depth of discharge. So, Gale, let's go a little bit deeper now. So let's add some more things on here to where we can actually get a really high number.
Okay, we talked about, Jeff, that TV, and we've got 200 watts and 9.3, and for an hour 18.6, and then we've got the satellite dish, and we've got the refrigerator. Want to keep things cool. We've got to have a coffee maker, obviously.
Exactly.
If you're like me, I've got to have my coffee.
You're exactly
otherwise
right.
I'm not functional. Anyway, and then we have light bulbs. We actually want to see
Yeah, we want to see what we're doing.
Yeah. And then we have blow dryers. We obviously, if we take our wife along, we've got to make sure that blow dryer is functioning.
Yes.
And sometimes those are 1,200 watts of power. That's still a lot of power.
That is a lot of power. So when we look at that, we got to have some batteries to be able to handle all that.
Exactly.
Well, we know that the RV industry has kind of changed gears from just their typical 12-volt batteries. So they're looking at 6-volt golf cart batteries. Well, how do 6 volts work in a 12-volt system?
Well, one of the things that I love about 6 volts, you and I both have talked about this, is that they're bigger, they're taller, they have bigger plates in them, they're made specifically for deep cycling, not for cranking of any kind.
Exactly.
They're not even rated in cranking in.
Exactly. So our example here that we're talking about, Gale, we've got 2 6-volt batteries that we've actually put in a series connection. So let's say battery 1 and battery 2. So battery 1, we're going to actually take that cable from the negative, and we're going to run it from that negative over to the positive of battery number 2.
Yes.
So that's a series connection. So what we've done there is essentially taking that voltage from a 6-volt to where we're 12 volts now. So that's done what with our capacity though, Gale? Has it doubled?
No,
Exactly.
Our capacity is going to remain equal to the lowest level.
Exactly.
So in this case, that 6-volt battery at 115 minute RC at 75 amps or 225 ampere hour is going to be 12 volts, but not above that same level of
Exactly.
current.
So what we've done there is essentially taken these 2 batteries, put them together, and now we've actually got the 12-volt capacity now that we needed to run the system itself. and we look at our capacity being the same as to what one battery would be.
Exactly.
Now, you've also got some folks out there that freak out and say, well, I can't do that. I'm scared of putting a negative and positive together. I want to run these things back in parallel. So I want to put me two 12-volt batteries in there. So what you've basically done is you've taken two batteries, and now you've kept 12 volts, and you've actually doubled the capacity of those batteries. So now we can actually look at that in our example here. We're talking about 1,000 CCAs, right? And we're talking 240 minutes on the reserve capacity side of it. So that is our total availability there now.
But even those two 12 volts, small 12 volt group size 27s as an example, you put two of those together, that still is going to be not as equal, not as big capacity as those two 6 volts.
Exactly, because you're looking at a bigger footprint now with these golf cart batteries.
Correct.
So we call that more real estate.
Exactly.
So the more real estate you got, the longer run times you're going to be able to run with these units and still have capacity available. So let's fill in a little bit now, because we throw a kink in the plan, because if you got to have more batteries, now we got to do what with these 6-volt batteries?
You've got to go not just a series, not just a parallel, but combine those two into what we would call a series parallel connection.
Exactly.
Connect two 6 volts together to get that 12 volts, but we want to enhance the current or the ampere hour capability, so we add two in parallel with that to get double the amount of ampere hour out of those 6 volts, or triple, whatever may be the case, depending on how many batteries you want to place in there.
And how much stuff your wife wants to run.
Exactly.
Exactly.
At any given day.
Because if mom ain't happy, ain't nobody happy. Exactly.
So yes, so connecting two or more in series with a parallel connection to the vehicle, we're going to maintain the voltage of the series, and in this case, we're going to then double the ampere hour capability. And so with any connection to multiple batteries, it's always essential. You and I have seen this so many times. If you're going to take those apart, take a picture of those before, so that you know how they go back. You and I have had so many calls that they'd get halfway through and they'd forget, now where does this wire go?
Exactly.
Where's that connection go?
And they call us to
Yes.
help them out. So we're doing this kind of blind. You know, we're trying to figure out exactly how this system is set up to where we can actually walk them through hooking these batteries back up appropriately to where they're not going to damage the system.
Exactly.
Because your
The computer
electronics
system.
won't like 24 volts if you
No.
accidentally hook it up wrong.
Exactly.
It'll hate that. So we want to make sure that we're actually avoiding any of that case where you could run into a situation of an
So
expensive
going
repair.
back, take a picture first.
Yes.
Picture
Take that
worth
picture.
1,000 words.
Exactly. And you'll be happy.
Yeah.
And Mama will be happy.
Yes.
So,
You'll
and we
be
also,
fine.
one of the other things that we also talk about, Gail, is the connectors themselves. So make sure that you got clean connectors that you're putting on. You know, heaven forbid, and a lot of folks will use a wire brush to clean off corrosion. Well, we know that doesn't get into the pores. So we want to make sure that we're using clean connectors when we're hooking these batteries up, so there's no voltage drop within there.
Exactly. That's very important. Clean and tight connections, but don't over tighten.
Exactly. Well, also, and I just thought about this. So we also look at different types of batteries. Would we want to mix batteries, Gail?
No, we want to keep the same type of batteries, the same ampere hour, same ratings, and same age if at all possible.
Exactly. That's the more matched the batteries are,
Yes.
the better they're going to work together.
Exactly. Right.
So let's key in about not using
Double
like impacts or
Right.
even the cordless drills,
Right.
because even those have a lot of torque on them.
Right. And that's very important, making sure that you don't over tighten them. We often sometimes use those drills, and we'll go in and tighten that that bolt, that nut with a drill, and that could over tighten. Make sure you don't use the Bubba torque on it
Yeah.
also.
Not that we've ever seen any.
No.
those. No.
Herculean.
Yeah. All right. So we're going to talk a little bit about maintaining your batteries to get maximum life out of these things. So we still want to educate everybody about there is a break-in period for these deep cycle batteries.
Yes.
You're looking at anywhere from 25 to 50 cycles to be able to reach full capacity. But once you get that full capacity, Gail, these things are going to hold that capacity for many, many cycles before they start to typically drop off.
Right.
But a key factor to making all this work together is, we always keep saying this, 50% depth of discharge. Well, how do you know if it's 50% depth of discharge? Well, you got to look at voltages, right?
Yes.
So
State of charge.
when we look at low voltage disconnect on these coaches or these boats, you could actually set a low voltage disconnect around 11.9 volts, which should keep you in that 50% depth of discharge range. So that way it's already fit and set in there to where it's going to stop once it gets to that 11.9 volts. So this way you actually get a really good recharge coming back in without increasing the heat, because
Yes.
resistance creates heat and that destroys the battery itself.
Yeah.
So we want to make sure that we're keeping that at that 50% depth of discharge so we don't damage the battery and we get a long cycle life out of it. If we're looking at seasonal use though, because not every state, believe it or not, stays at 80 degrees throughout the year.
Hawaii.
That's true. And unfortunately we're not in Hawaii.
No.
And unfortunately today we're 27 degrees.
All batteries want to go there.
Yeah, all batteries want to go there, and we just can't get them to ship over there and be able to use them right over here.
Yes.
So that's a big negatory.
Yeah.
So we want to make sure that if we're putting these things in storage, to charge these things efficiently before you put them in. Check your water levels, because if you're putting it in there with a maintainer charger, and we'll talk about chargers in a minute, we want to make sure that we've got it fully charged before we put it in there.
Absolutely.
So that way, you can actually rely on it to be ready to go when you come back out and want to go on your fishing trip.
Yeah, because you're ready to use it.
Yeah, exactly. All right. So charge them before you're storing them, and just basically monitor the temperatures as well. So if you're looking at a temperature of 32 degrees or even lower, the self-discharge is going to be a lot slower, right? And that's if it's not hooked up to a charger. So that's not a bad thing.
Right.
But as the temperatures get hotter, past 80 degrees, you actually have a self-discharge that actually increases. So always keep that in mind as well. And what we can actually do is, if you're not power available for storing these things, you really need to go back every couple months, and especially if we're going to be in long, drawn-out storage, charge these batteries some way every couple months, so that way they're not sitting there. And internally, they're going to sulfate, because acid's heavier than water, and it's actually going to migrate into the plates. When it does that, if it sits in there long enough, it'll actually start sulfating the plates, and that actually will hamper your run time. So then mama really ain't going to be happy.
No. So you need to make sure that you keep it activated.
Exactly. Now, let's talk about chargers, Gale.
Chargers, for example, that's key to what your battery's going, the longevity of your battery. So charging deep cycle batteries. Let's make sure that we select the correct type of charger. Make sure it's fit for or made for the type of battery you're charging. In this case, we want a deep cycle battery charger. We want to make sure it has a maximum of 20 amps for each 100 ampere hour of battery capacity. You got a 100 ampere hour battery capacity, you want to make sure you get a 20 amp charger or less to maintain that. And then you want to use a smart charger or an automatic charger, one that's got brains to it.
Yeah, not a smart aleck, smart chargers.
Yeah, and this smart charger has something built into when it gets to a certain level of voltage, it's going to kick into the next stage. It's going to know and tolerate what's going to happen to the battery temperature-wise, etc., and not overcharge and or overheat the battery.
Exactly.
And so make sure it has the correct settings for the battery type, whether it's AGM or it's a flooded battery,
Or even
etc.,
gel.
or even gel or enhanced flooded,
Yes.
etc. Make sure it's the right one. And then trickle chargers will maintain batteries, not charge, not overcharge a lot of times. You want a maintenance stage on that. It may not say trickle, may not use the terminology trickle, but
Yep.
it may say a maintenance stage. That's maintaining the battery. Remember though, if you don't get it up to 100% state of charge and you put it on maintenance stage, it's just going to maintain that level of charge. So make sure you charge it up and then maintain it.
Like that either.
No.
Mm-mm, not at all. So let's talk about maintaining the batteries for maximum lifespan. So charging your deep cycle batteries, we want to make sure that we're keeping safe.
Yes.
Right? So we talk about PPE, your safety. So gloves, glasses, jeans.
Yes.
Unfortunately, acid. Battery acid really likes jeans, denim jeans. So you're probably going to have some jeans that actually go to church a lot. So they're holy.
Yes.
And we know that because we've seen them. We want to make sure that we're checking the water levels, and if it's below the plates, you definitely got to add water, because you're exposing lead that actually is designed to be submerged in this liquid electrolyte. So when you start opening that up, you actually start a corrosion process. So you've got to make sure you've got water that's actually covering the plates.
Yeah.
So now, what kind of water do we want to use, Gail?
Well, deionized or distilled water.
Bingo. And so we want to make sure that the plates are actually covered. So we've heard stories,
Yes.
throughout of all of our training that we've done out there. So we don't want to use lake water.
No.
That's nasty.
No.
We don't want to use seawater because that's got salt, right?
Exactly.
We've also heard about man-made water.
Yes. We don't want to use that.
Yeah.
That's out.
What is that? That's like the yellow in the snow.
Yes.
Yeah. We don't use any of that.
No.
So we want to make sure we're using distilled or deionized water and it's actually covering the plate. So that way we are putting in what needs to be taken care of. Sulfuric acid is not ever going to leave the battery, right?
No.
Unless you turn it over.
What happens during gassing, normal gassing of any battery, is that you have 2 parts of hydrogen and 1 part of oxygen. That's H2O. Which
exactly.
Is
so yeah, we want to make sure that we're actually putting back in what we need to. Now, we've also heard stories about people wanting to use Gatorade because it's got electrolytes.
right. It's got electrolytes.
That's a different kind of electrolytes, guys. We don't want to use that.
Absolutely not.
We also want to talk about the charging side of it. So keep in mind that you got different charging rates within this battery charger itself. So the first stage that we go through, Gale, is bulk. And what that means is it's going to put the bulk of what you took out of that battery first. So we could put in anywhere from 75 to 80% of what you took out. Well, from there, we go into a absorption stage. Now, this is going to put back in about 15 to 20% more of what was taken out. So now you're getting pretty close to being to that 100%.
Yes.
And then we go into a float mode. So what that basically does is just stop with the amperes. It's going to be very low. So it's basically just a finishing charge. And then it's going to maintain that as it's setting there. So what we want to make sure of is that we give this thing ample enough time to go through all these stages to be able to make it all, get the battery up to where it needs to be and make it spend a lot of life.
On a smart charger.
Exactly. When we look at the time, this can actually be 2 to 3 times the amount of what you spent running this product down. So let's say you spent 8 hours fishing. And so now you've got these batteries down to 100% depth of discharge. This could take 16 hours or longer to be able to charge this battery back up efficiently. This doesn't happen in a matter of an hour, and we get that story all the time. We want to make sure that we're educating those folks on that as well. Monitor these things because, if you're smelling a rotten egg smell and it wasn't you or your buddy,
right,
then typically it's going to be the battery.
It's going
so
to be the battery.
we want to watch out for that because we can get what we call, Gale, you put this out there years ago, we call that a rapid disassembly. Now, what does that mean? That battery's going to come apart quick.
Yeah.
And so we want you to be safe. So our little example that we're showing you on the screen, so you got this 12-volt battery, and you've got 6 individual cells in there, and they're all connected in a series connection, kind of like what we were talking about earlier in series connections. So internally in the battery, it's a series connection. So we've got 6 cells in there that should be producing the exact same thing across the board. But if we've got one cell, which in this case we're showing only 400 CCA or 120 reserve or 70 ampere hours, so that's going to be our total power availability.
Never going to be any stronger than that.
Exactly, and you guys know this for working on vehicles and whatever. In a series connection, you're only as strong as that weakest link.
Yeah.
Same thing in a battery. So, unfortunately, in a case like this, we could have that accidental rapid disassembly, or we could get to the point where we're not getting any run times. In a case like that, checking specific gravities, we'll be able to educate you on that battery itself. If it's bad, you're never going to heal a bad cell. So replace that battery, get it out of the mix, put you in a new set, and keep moving on down the road.
Okay, thanks Jeff and Gale. We want to allow plenty of time for Q&A, so keep putting those questions in the toolbar. While Jeff scrambles back to his desk, I'm going to sum up what we talked about. We talked about the industry outlook for marine and RV. Both are very sunny, both are looking really good. However, parts, including batteries, are constrained. So one part that is not constrained, however, is the new Interstate EFB. It's not available in all areas, but it is twice the cycle life, twice the warranty of our traditional flooded lead acid battery, and just a little more money. So it's closer to an alloy AGM in performance, but more like a traditional flooded lead acid in price. We talked about working with your customers, helping them understand battery types, battery chemistries, helping them set up the right system for them, not just selling them a battery, but what are they using? What do they need? Calculating their amp draw, putting the right battery in series or parallel, and then taking care of those batteries so they last longer. Understanding break-in periods, understanding watering and charging. All of this to help them have a more positive experience, which is what you need to do to keep those customers coming back to you. So without further ado, I'm going to hand this over to Jeff, and put your questions in the Q&A tool, and we'll get them answered. Thanks. All right.
Well,
Okay.
hello, everyone.
Hey, let's see, camera on. All right. Well, we have a lot of really smart people on this call, so we only have a few questions. And maybe this could be more of a conversation than a question. The first question we got was, how are the enhanced flooded batteries performing? So you've been testing these for a couple of years, or been watching them, and how do they compare to Optima's gel cells?
So Optima is actually an AGM battery. Everybody, for the years and years and years that I've known, everybody thinks it's a gel product, but it's actually an AGM, absorbed glass mat. It's a spiral cell design, so that's why they get they call it the 6-pack design. A lot of vibration resistance in there, just like any of the other AGM product that you're looking at. I will say, though, that when you look at performance, now you're talking a pure lead product here. That's what Optima batteries are. They're pure lead. So with pure lead, you can get a lot of cycle life. There's no question there. EFB, you can get a lot of cycle life. You're not going to get just the same as what you would with the pure lead. There's no way around it. And of course, the price kind of reflects that as well. Really good performance, though, so no questions around that. When you look at EFB, you can actually get, if not more, the same of what you would with a alloyed AGM. So there is some differences there that kind of work in your favor. Pricing for the EFB is cheaper than what you would pay for an alloyed, and it's a heck of a lot cheaper than what you would pay for pure lead. But you're looking at a flooded product, maintenance free, true maintenance free. You can't get in it. So performance wise, I would say that EFB not on the same level as a pure lead Optima or our MTZ or our 34M AGM product. So good performance, though, not any question around that, but there are some differences.
And Derek Hawkins asks, what happens if you over tighten the battery?
Over tighten the battery?
When you're tightening the connections. Yeah, the nut on the battery.
So keep in mind that this stud that you guys see is basically an inverted bolt that is actually molded into that lead pad, when it's, solidified. So once it hardens up, that bolt is actually in there just as a tightening point. So when you put the eyelet connector down on that stud, you're using the nut to push that eyelet against the lead pad. If you over tighten that, in which we have seen a lot of people do, you actually pull that stud up out of the lead. Well, unless you got your magical tool to be able to melt that back together, you're pretty much done, unless you've got that other automotive SAE post that you can actually use. So be very cautious there. And we do have the torque specs for all of these. So if you don't know them, please reach out to us. We've got that information on hand, so that way you're not over tightening it. There's a lot of bubbas out there that don't know their own strength. So we want to make sure that we make sure that we're not over tightening to where we run that risk, because it's not a warranty issue when you bring it back with that stud out. I'm sorry, but we didn't build it that way. So.
Yeah. All right. Marilyn asks if you can have a copy of the PowerPoint. Yeah, if you'd like a copy of the PowerPoint, just put that in the chat or the Q&A, and I'll email it out to you. Not a problem. Send a PDF of it. There was another question, one more question. And guys, if you have any questions, open the Q&A tool on the Zoom toolbar and pop it in there. Otherwise, we have one more. Some customers want to know, what is the difference between AGM and gel deep cycle batteries?
Yeah, and Gail kind of alluded to the answer on there as well. So AGM and gel, totally different. So AGM has got a absorbed glass mat that goes in between the positive and negative plates. So you're taking basically liquid electrolyte that you would see in a flooded product, a little higher acid content, but you're basically pressuring that into the individual cells, and it absorbs from the top to the bottom, saturation wise through the mat. When you look at gel, so gel is a little bit different. It is like a liquid electrolyte with what we call a silica base. So that silica basically enables that to gel up. So now your electrolyte, instead of being, fluid moving around, it's gelled up to the point where if you were to have a, accidental drop and you crack the case, it's not going to leak out. Same with the AGM product, it's not going to leak out. So there is a huge difference there. Believe it or not, even with that being a gelled solution in there, the internal resistance is actually a little lower than what a AGM product is. So if you look at charging parameters, we're anywhere from 2 to 3/10 of a volt difference in charging on an AGM, which is lower than what it is, on a gel, and it's 3/10 lower on the charging regime. So when you look at that, and an unfortunate thing is a lot of the mobility scooters, a lot of those are actually designed off of the gel product. So we try to sell a lot of AGM product into gel, and 9 times out of 10, it doesn't work well because it's got a different charging parameter. We need a little bit more push on the AGM versus what we have on the gel. And keep in mind, guys, if you didn't realize, we actually do have gel product as well in our lineup. So get with your route guy or your distributor, ABC store, whatever. We do offer the gel product in several different sizes as well.
Got another one from Jeff. He says, what do you think of voltage sensitive relays versus DC to DC chargers when working with house and starting battery banks?
So we like that, and we've dealt a lot with the DC to DC converters alongside like golf cart applications, because when you're looking at golf carts, you got a 36 or 48 volt system. Well, you've got 12 volt accessories that you need to run off of that, like lights or beacons or stereo or whatever. So what we like to have is a DC to DC converter that actually matches the voltage that we actually have on board, especially with golf cart. So we take this DC to DC that converts 36 or 48 volts back down to 12, but it's using that whole pack of batteries, and not like we've seen at some of the industrial locations that we've been at, where they'll take 2 6-volt batteries that are within this 36 or 48 volt pack, and they run leads off of that to get 12 volts. Well, you're basically taking from 2 batteries while the other ones are still there trying to survive. And all of these are in a series connection. So we like the DC to DC converter where we're actually using a whole pack and consolidating it down to whatever voltage it is that we're looking for. On the AC side, it's still, you're looking at an inverter going from AC to DC. So you got to make sure you got a big enough inverter to take care of whatever power you're looking at to try to run with the ample bank of batteries as well. Gail, you want to add on that one? I think he's on.
No, I'm good with what you just answered. Some of the things that I think the question was with switch relays, am I correct?
What do you think of voltage sensitive relays versus DC to DC chargers when working with house and starting battery banks?
Yeah, there's some good merits on both sides. We find that in our situation, most of what we deal with is a DC to DC converter, but I've nothing against switch relays except the situation. Make sure that switch relay is robust enough, because you're going to get some arcs and sparks through any type of relay or connection where you're going through a central point there with that much power, and you're going off and on. You get an arc every time that happens of some kind.
Okay. Getting some more questions coming in now. Okay, some chargers have different settings: 25, 0.5 amps, etc. What setting is best?
Well, I think, Gail, you said it earlier about the 100 ampere hours. So for every 100 ampere hour battery that you've got, at least 20 amps for that battery. So that way it's charging it efficiently and, in a timely manner at that. The lower you go on amperage, the lower wattage that you actually have. So because they're trying to keep everything protected as far as the circuit boards, so it'll actually keep the voltage lower. So when you look at the 0.5 amp or even 1.5 or 2 amp, they're kind of wattage regulating that to where it doesn't over exert. So you're going to keep it in the 14.4 to 14.6 range. And on a flooded product, you're probably going to need a lot more than that. So that's where that 20 amp is probably going to be the best for flooded, because that way it's actually pushing into where you're and it's not uncommon to see 16.5 or 17 volts on some of these chargers. As we monitored them with some of our data collection equipment, you'll see spikes of 17.5 volts, but it's microburst. So it's in like tenths of a second, but it's actually kind of pulsating through there to kind of help clear off the plates. So it's not uncommon to see voltages that high. So once again, getting back to the ampere hours. So if you got 100 ampere hours, 20 amps is what you need to push at it.
Let's see, we have about 40 people still on the call. I wanted to ask if this is kind of an informal poll question. If Interstate were to create an online calculator where you could work with your customers, enter the appliances they're using, the accessories, and it would help you put together an assortment, a series of batteries for a battery bank, for instance, would that be a useful tool? Just answer yes or no in the chat while we move on to this other question. But basically, it'd be on our website, customer could enter their waffle makers, whatever appliances they're using and how many hours they're using it for, and help you determine what's the best battery setup for them. Would that be useful?
I saw another question on here from Bob, and then we'll kind of go down through the line with some of the other ones. For a trailer that is parked or stored for long periods of time, should the customer disconnect the batteries? Yes, I will say that, but there's a caveat to that also, Bob. When that thing gets parked, we want to make sure that that battery's at 100%, because battery sitting there will self-discharge, and it's usually anywhere from 3 to 5% at 80 degrees. As the temperatures get higher, your self-discharge rate gets faster. As the temperatures drop, it gets slower. So that's why we want to make sure that we got a fully charged battery before you leave it sitting there, either direction. Because as the temperatures start dropping, if that battery was already discharged, it can actually freeze at 28 degrees. And that's not a good thing. Hopefully that helped you out a little bit.
You need to have all the water in them, right? When you store them, that could make it freeze earlier too.
Yeah.
I know I'm not supposed to answer the technical questions. Sorry.
Just did. We're happy for you.
What Frank asks, what's the best way to check an AGM battery?
Drop it off of the roof. Just kidding.
Drop it off the roof.
Sorry, that was the old thing.
If it leaks, it's not an AGM.
So testing an AGM, I mean, really, you can only do voltage, and you can use a conductance tester or a discharge machine, depending on what battery it is. Conductance testers are really good for starting batteries, that's for sure, because you're looking at an impedance that you're looking resistance-wise, going back and forth. So you can get a good variable there. If it's a deep cycle AGM, the best way is using a discharge machine, because using a carbon pile load tester on a deep cycle AGM, you're basically doing a 15-second high amperage rate, to see how it's going to hold up. Well, it may hold up great for 15 seconds, but if you started with a 25 amp discharge and only ran 20 minutes, well, then we know that there's an issue one way or the other, whether it's a good battery or just worn out. So that's kind of what you're needing to look at. Load test is fine for starting batteries. Conductance test is fine for starting batteries. If you're looking at deep cycle AGM, it's best to use a discharge machine.
The only thing I would add to that, Jeff, is you're exactly right. A discharge machine. Make sure that the battery's at or near a full state of charge before you start that process. Had a guy that brought in one, and he had run a discharge machine on it, but he started at 12.3 volts, which was a low state of charge in that situation. So if that battery's at or near 12.8, 12.9, 13 volts on a 12 volt battery, yes, you can use that discharge machine and try to get yourself a time frame of how long it will discharge, 25 amps or whatever.
Perfect.
Good points.
It is from Mike. Is it acceptable to install a new deep cycle battery into a 1-year-old? I guess he means with a 1-year-old deep cycle battery that tests good.
And Gale and I have dealt with this over the years, and especially when you're looking at like dual batteries in a application that's truck, because it's going to take that new battery and it's going to bring it down to the level of what that older battery is, even though it's a year old. So you're basically taking that new one and you're going to shorten the life of it. There's no question there. As to how many cycles, who knows? I mean, if the battery's testing good, and let's just say you ran it through a discharge and it's, pretty spot on with what the ratings are. I mean, I can't say throw it away and get, 2 brand new ones, because, today's, especially cost wise, it's not feasible to do that. So, if they're
A
testing
solution, but
yeah, the best solution is replace them both. But in a case like this where it's a year old and it's still, testing really good, just personally myself, I'm probably going to put it in there. I know in my mind, because of all the testing we've done, I know it's going to shorten the life, but I just don't know how much. And, what's the benefit, of just taking both of them out? That's a lot of money.
yeah. Okay, so this from Jeff, and it may be a two-part question, Jeff Matheson. I work with marine systems with house and starting 12-volt banks. Not sure if a DC to DC charger versus a voltage-sensitive relay that auto parallels when the engine is running. Is it good? And I think the other question is the second question. Is it good to jump the starting batteries over to house for charging? Does that make sense?
Well, so if you're going with starting and you're looking at a house, well, we know that house has got a higher resistance because they're bigger plates, thicker plates. So I don't know. And I know we've got a lot of folks to do that with some commercial applications. I mean, that's a tough one, because you're kind of putting a strain on the alternator, number one, to keep charging. Man, I don't know. Gail, I'm going to let you take this one. I'm
Never stumped him before.
Yeah, that's one that,
As I understand the question, I would say no. Let's don't choose to do that, because let's think about these as two separate systems. Your starting system is different than a deep cycle system, so use those or take those separately from that and charge those individually. Will it recharge that deep cycle battery? I don't know, because we don't know what the settings are, etc., and how discharged the battery is. But you may overcharge one trying to get the other one up to par. So I commit those are separate systems, so charge them separately, if that makes any sense.
Jeff also adds, it's super common practice in Boston Whaler electrical design, but I think it's bad practice. I'm going to try something we have not done before and see if Jeff would like to talk. And then we can do this.
oh, is this your boom boom?
No, this is bomb bomb. No, this has nothing to do with that. Jeff, if you're on the call and available, I don't know if you have any follow-up questions you'd like to ask.
Can you guys hear me?
Yes, sir.
We can.
Hey,
Yeah.
how you doing? No, I was just that's the way they design all these boats that they send to us, and so they run the batteries on like just a 12-volt house battery, usually requiring AGMs, and then when the engine starts, it just automatically parallels the starting battery once it gets up to a voltage, and just jumps it over to the house, so that charges up both batteries. But I mean, if they're going to always be in dissimilar states of charge, if you're using any of your gear for, so I just think, and we've seen it a lot. They started doing this like 5-6 years ago, and we've seen a lot of batteries, especially that house battery, going bad pretty quickly, I would say. So, would like a DC to DC charger be a better choice instead of a voltage sensitive relay? So it will actually go through charge phases, like maybe a 20 amp DC powered DC charger.
I would think more along that lines.
Yeah. Okay. Yeah. I just wanted to get some professional opinion on it, because that's what I would like to push the industry to do. But it's literally a whole industry that's installing like this.
Well, and so Jeff, let me ask you this: is that part of the ABYC standards?
I will have to look into what the actual official ABYC, but dealing with multiple battery banks on a boat, I think it's pretty common to just jump the the starting bank over to the house and get it to charge up. But it's not gonna be good for the battery system. I don't.
Yeah,
Well,
it's not the optimum system,
yeah.
I don't think.
Right. Okay.
Well,
Cool.
especially if you're seeing batteries, you're having to swap out.
Yeah, I mean, it's like these $400 AGM batteries, and they last 2-3 years. Of course, they only get used for 3 or 4 months a year. We
Yeah.
charge them up fully when we put them away, but they sit there for probably 6-7 months, and then we
Yeah.
take them out again.
Well,
So-
Jeff, if you can find out even the ABC or ABYC, yeah, if you can find the just the test standard number, because I've got the test standard here that we keep on file. I mean, I can dive through it, but there's like 1,800 pages.
Right.
But I mean, we don't have a problem checking it out just to see, because we're working with that quite a bit with some of the other boat manufacturers.
Well, and another probably the only other alternative to keep everything charged with just really the one engine or 2 engines or whatever is to use an isolated charge output.
That's what I was getting ready to say, an isolator.
Yes.
And how is that compared to those other options?
It's better because your isolators are built for that type of thing, to isolate, not to change, not for those battery systems to go between, but to work separately and charge each one individually, sensing what its needs are.
So the isolator will do that. It'll kind of adjust the voltage for that particular bank.
Absolutely.
Okay. Great. Well, thanks so much, guys. That's all the questions I have. I'm going to unmute myself again.
Oh,
Thank you.
man.
Thanks, Jeff. That was awesome. That's the
Hey, we
first time we've done
appreciate
that.
I was gonna say it's the first time we ever had that on there.
Yeah,
Cool.
it's getting crazy here. Mike Walker asked the question, can I install a 12-volt battery onto 2 6-volt batteries to add capacity to an RV trailer?
No, it's not recommended. It's almost like mixing batteries of different chemistry. So no, we don't want that. Remember, this is where Ohm's law comes into play, Mike, and that's where current follows the path of least resistance. So you're going to overcharge your little 12-volt. You're never going to fully charge your 6 volts, even though they're in 12-volt series connection. So that's a big no-no. I mean, we know a lot of folks that have done that, or at least tried that, and then ended up, fussing because, man, I just don't seem to have any capacity.
Yes, I would agree with that 100%.
That's all the questions we have, and we've gone over a little bit on time. So
Man,
really appreciate everybody who joined us. If you have any more questions, you can pop those in the chat, but we'll or in the Q&A. But thank you for joining us, and Jeff and Gail, as always, thank you for your time doing this.
Oh, you're very welcome. It's great to be on. And Kyle, I was going to say that I noticed the yeses took over, or was 100% of the answers a while ago when you asked the question.
we knew that's what it was going to be.
Yes.
Well, I would like to think so, but certain people that write
Don't
the
say it.
checks. Yeah, okay. I have to prove it.
Yes.
So
I think there's a lot of proof there.
yeah, sounds like there's
Yes.
a couple people that would like a calculator. So
Yeah.
Hey, we sure do. Thank you guys for being on. Or
Yeah,
people
definitely.
For being on, I should say.
thanks very much, guys.
All right.
Thank
See you guys
y'all.
later. Have a good afternoon.
Yes.
Bye.
Bye.
Bye.